Hi, good morning all. Welcome back to our channel. Today we are going to solve some problems on Millman's theorem. So before solving this Millman's theorem, let us try to know some basics and statement of Millman's theorem, and then we will apply this Thevenin Millman's theorem onto our problems. What is this Millman's theorem states is when a number of voltage sources like V1, V2 and so on, if you have n number of voltage sources and all these voltage sources are connected in parallel. So this type of experience you generally have in Genco. Okay, so the Genco we generate the power. We have small synchronous generators which will of 1 megawatt like that, which will be connected in parallel. Okay, so number of voltage sources or multiple generators connected in parallel, and they have an internal resistance of R1, R2 and so on up to Rn source. This complete network, okay, so for example you have one more generator here. Okay, this complete network can be replaced by a single circuit. This is nothing but single electrical circuit. So this is a single electrical circuit consisting of an the equivalent voltage source and equivalent resistor and replace the removed load resistor. Okay, so this is what the concept of Milliman's theorem. Okay, so this theorem is more applicable when you have more generators are connected in parallel. Okay, in generating station they have around 4 to 5 generators. For example, they want to turn off one generator, automatically they'll turn off only one generator and remaining three will be in action. Okay, for example, if you have a single generator rather than having 4 generators, if any problem is there in single generator, complete power will be interrupted. So in order to solve this problem like this, multiple generators of smaller units will be installed in parallel. Okay, so this is the concept. So when you have this type of multiple generators connected in parallel, that can be replaced with a single generator. That is the concept of Milliman's theorem. So now let's try to find out what is the formula for V equivalent. We want voltage. V equivalent is equal to, what is the voltage here? V1 into, so this we have to write down as 1 by R1. So the units of 1 by R1 is mhos. Okay, so you will get out the units of R1 is ohms. Okay, so R1 inverse. Okay, when you write down the inverse of R1, okay, what is the inverse of R1? Is nothing but conductance. Okay, then we can write down the units as mhos plus second generator divided by, so here we are writing as 1 by R1. Automatically in the denominator also you will have R1, then automatically R1 will get cancelled and resultant is an voltage if you have only single voltage source. Okay, if you are having more than two voltage source, then we have to write down V2 into 1 by R2. Okay, so the units of R2 is ohms. 1 by ohms is nothing but mho, and similarly you add the second R2. Okay, so then these two also will get cancelled out. So this is valid until you have multiple generators. Okay, so sometimes the polarity may change. Okay, so and so on it will be continued, and I'm having an generator generating a voltage of Vn divided by 1 by Rn. Okay, so 1 by Rn units is mhos, and this will also will be continued, and this will be 1 by Rn. So this formula you can write down in one more way also for your understanding. So this I can write down it as V1 into G1, where G1 units are mhos. Okay, so this is nothing but then G1 we are going to call it as conductance 1 by G1 plus or minus V2 G2 and so on up to Vn Gn divided by, so this can be written as G1 plus G2 and so on up to Gn. Okay, so this is what the formula we have. So you will get a dot here. Current, all these currents are moving only in forward direction, then we will get only positives. If example, so this source is in this direction, so this is positive and this is negative, then you will get minus. That what you should understand while solving the problem. So the same question may not be given in the exam. He'll test how you are able to analyze. So here the current will flow in this direction. Therefore, the current direction is reverse. Therefore, you will be getting minus V1 into G1 plus V2 G2. Now, so successfully we find the value of V equivalent. Now we require the value of R equivalent. So generally we can use the formula 1 by R equivalent is equal to how many generators are connected in parallel? 3. Okay, I can write on it as 1 by R1 plus is nothing but the formula of R equivalent. Generally the formula of resistance when multiple resistors are connected in parallel. So 1 by R1 plus 1 by R2 and it will be continued up to 1 by Rn. Or you can write down in one more format where R equivalent R is equal to how much? The units of R is how much? Ohm. So this can be written as 1 by G equivalent. The units of G is how much? Mho. So this I can write down it as 1 by G1 plus 1 by G2 and so on up to Gn. So since it is in conductance, so G is called as conductance and we can add this conductance. But how to write down? But actually G is not given in the question. We require to write down it as 1 by R1 plus 1 by R2 and so on divided by 1 by Rn. So this would be the formula to find out R equivalent. R equivalent is equal to 1 by R1 plus 1 by R2. So this 1 by R1 we can write down it as G1 as a conductance. This 1 by R2 I can write down it as G2 and 1 by Rn I can write down it as G2. Then we obtain the second part which is nothing but R equivalent. So just how to find the current IL. So I want the current in this branch. Okay, how to find out IL? IL is equal to what is the total voltage? V equivalent minus 0 divided by R equivalent plus RL. By using this formula, we can find out the value of IL, the load current in the given question. So this is the way of solving the problem. Okay. So hope you are able to understand. Millman's theorem is generally used when you have multiple sources are connected in parallel and they are having an internal resistance of R1 and R2 can be converted into a simple circuit consisting of V equivalent and R equivalent, and this is the procedure of solving. Okay, the formula for IL, the total voltage V equivalent minus 0 divided by, you can see here these two are connected in series. Whenever they are connected in series, this is nothing but R equivalent plus RL. Hope you are able to understand the problem. Let's try to solve some problems and you can understand better. Okay, thank you for watching the channel. So if you feel my explanation and way of solving is good, please give a like, and those who are studying the same subject, share to your friends. Still, if you have any doubts in my explanation, let me know in the comment section. And if you're watching the channel for the first time, subscribe to my channel with the name KV Ram. Please kindly support this type of free channel for the development of students and faculty. So thank you for watching. We'll meet in the next video. Yours obediently from